Hello there, Mr. Chan here for Algebra 2. About to do a new section 10-2, matrix multiplication. Turn your note takers and turn to page 239. Let's get started here. Now, the previous section we did an operation called scalar multiplication. This section is not scalar multiplication. Write that down. But matrix multiplication. When we multiply matrices together, we'll refer to them using uppercase letters, A and B, or whatever uppercase. The question might be presented this way: find A, B. Capital A, capital B means matrix multiplication, not scalar multiplication. Recall, scalar multiplication is lowercase. Here's the thing with matrix multiplication, which may not make sense until like later on. You want to look at the dimensions. Oh, by the way, I've decided for the video, I'm going to skip the opener and just give you some information on how to multiply matrices together. I realize that the opener is really just an introduction to how to look at costs and repairs and revenue, but they don't really get heavily into the problem, so I'm just going to skip it this year. Now, the dimensions, when you are multiplying matrix A with matrix B, are as following. Let's say matrix A has dimensions m by n, and matrix B has dimensions n by r. Remember, m and n, or whether it's n by r, the first number is the number of rows, the second number is the number of columns. In order for you to multiply two matrices together in this order, the number of columns of matrix A must meet the number of rows in matrix B. In order for you to allow you to multiply these together. Let me write that down. The number of columns in matrix A, or of matrix A, must equal to the number of rows of matrix B. One way of looking at it is the inner numbers must match up. You see those two? Those are the inner numbers. When you multiply the two matrices together, and I haven't shown you how to do that yet, we'll get a new matrix. We'll call it matrix C. The answer. The weird thing about matrix C is that its dimensions will be dun, 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 m by r. The numbers that were not, the numbers on the outside right there. M by r is the number of rows of matrix A by the number of columns of matrix B. Let me say that again. Matrix C is the number of rows of matrix A by the number of columns of matrix B. That's what I meant to say. Sorry about that. I might have misspoke there. Now, what do we mean? What does that mean? All right. Here's what we are going to do. Matrix C is represented by, generically right here, using brackets to represent the matrix, this configuration. So I drew some blanks here. Generically, I chose to write down row 1, column 1, row 1, column 2. Those spots have addresses on them, so I'll write them down generically. 1, 1, 1, 2, and I even wrote another one down here, 2, 1, and et cetera, okay? What that means is this. How do we multiply? We're going to take matrix A's rows and multiply them with matrix B's columns for each spot. That's going to sound kind of weird. Let me say it again. So in each element of matrix C, it is the sum of the products. Write this down. Sum of the products. What products, you're saying? Well, let me explain. The product will be the row number of matrix A. It's going to be kind of weird. Hang in there. And then couple that with the second number, and that second number refers to the column number of matrix B. It's very weird, but I'll show you how to sort that out in a moment, okay? You'll get the hang of it. It takes practice. This is one of those things that are kind of weird. So let's just ignore this space right here, and let's try one together. Let's just make something up here off to the left, okay? Here we go. Let matrix A be a 2 by 3 matrix, okay? I'll just make something up here. 1, 2, 3, 4, 5, 6. Okay, that's easy. It's a 2 by 3. Matrix B, we'll make it as a 3 by 2 matrix. We'll do it this way. -8, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. This is a 3 by 2. Question. Find AB. First, you got to see if you can find A times B. The dimensions of matrix A are 2 by 3. The dimensions of matrix B are 3 by 2. The inner two numbers match up, so yes, you can. When you multiply the two matrices together, your final matrix, we'll call that matrix C, will have dimensions of 2 by 2, okay? It will be a 2 by 2. Let's draw a big matrix here with a 2 by 2 representation here. Let's write the address numbers. 1, 1, 2, 2, 1, 2, 1, 2. Okay. All right. Each address in the blank matrix represents, the first number represents, as you remember, the row number of matrix A. So I'm going to circle the rows of matrix A as row 1, row 2. The second number represents, and I'll use red to contrast it a little bit better, the column number of matrix B. Those are these guys right there. All right. So let's see. It's row 1, row 2, column 1, column 2. Okay. So remember, we're trying to do the sum of the products. Here we go. In row 1, there are 3 numbers. In column 1, there are 3 numbers in each of those matrices respectively. So what I'm going to do is basically multiply each of those numbers, add, multiply, add, multiply. So watch. 1 times negative 9. See what just happened there? 1 times negative 9 is what just happened there in row 1, column 1. It's row 1 of matrix A, column 1 of matrix B, plus 2, -7, right here, plus 3 times -5. And that's how you do matrix multiplication. Row 1, column 1. Isn't that weird? All right. Let's get to the second empty element. Row 1 of column A, and then row B of, sorry, column 2 of row B. Tongue twisted there. Here we go. Check my math here. I'm doing this row with this column now down there, okay? All right, so let's do that. This would be 1 times -8 plus 2 times -6 plus, and I run out of room sometimes, 3 times -4. Great. Let me see if I can erase this part. There we go. Great. That takes care of 1, 2 for the address. Here we go. Let's do 2, 1 next. 2, 1. Here we go. 4 times -9 plus 5 times -7 plus 6 times -5. Awesome. Next one. Last one. 2, 2. 2, 2, like that. Here we go. 4 times -8. This is weird, I know. There are a lot of applications we don't necessarily cover in this course, but trust me, it leads to other amazing, crazy engineering and programming technologies. You're just touching the surface of this particular one. All right. So here, you just have to clean it up after you've done that last sum of products there, okay? Makes sense there? So I'm going to delete that, delete that. Oh, shoot. Oh, my goodness. Sometimes that eraser is dangerous. So let's clean this up. I'm going to do a little math here. -9, -14, -15, -8, -12, -12, 36. I don't know. Mr. Cheng had to do this by hand when you were in high school? Yeah. A lot of work. So when you clean that all up and you sum it up, you'll get -38, -32 in the first row. Second row, we have -101, and the last row, -86. Yeah. So kids, we're going to do that again with the same matrices, but in the other order, okay? And let's see what happens there. Are we going to get the same product? Let's go and find B times A. Any questions on A times B? Let that, pause the video. Let that absorb into your brain a little bit. We're going to find BA and call it D. Now, B is a 3 by 2, and A is a 2 by 3. Note the inner numbers do match up, so we can multiply B times A, so yay. Sometimes you can't. And your final matrix D will be a 3 by 3 matrix. Let's go ahead and set that up. And let's put in the addresses. Now, in the initial example here, I showed 1 times -9 and 2 times -7 and 3 times -5. You don't have to write that. You can actually just write the -9 plus -14 plus -15, for example, okay? So in this right here, I'm just going to go ahead and simplify it in my head as I set up the problem, okay? I do need to rewrite it again because it's harder to see up there using this spot. I can't use that. I got to write it in a certain order for me personally. So it's B first. So I'm just trying to give you guys some techniques and tips. Times A. So in my mind's eye, I'm going to do the rows of this way and the columns this way for my first product. Okay, here we go. Negative 9 times 1 plus negative 8 times 4. Bam. Okay. Row 1, column 2. Here we go. Negative 9 times 2. And there's only 2 products here. That's very nice. Plus negative 8 times 5. Great. 1, 3. Negative 9 times 3. Plus negative 8 times 6. It's a lot faster. You don't have to write out everything. Just do the product in your head. It's so much easier. Next row. Oops, I think I lost a negative. Yep, I did. Be careful. Row. Oops. There we go. There we go. And maybe you can do this in your head too. And I'm just going to do it quietly here. Oh, I did mess up, didn't I? Negative 7 times 1. Ha ha ha. You got to be careful. These things happen. They do. I'm doing the 2, 2 next. And I'm just using the highlights to show you where the 2 row column things I'm concentrating on here. Okay, looks good. 2, 3 is next. Whoops. And we'll get this. And we're ready for the 3, 1, 3, 2, 3, 3 addresses next. Okay, great. Ooh. Oh. Did I change it up last year? Let's see, negative 9, negative 32. Something must have happened last year. Sorry, but let me double check everything, okay? Yeah, the notes are different from last year a little bit. Must have changed it up a little. Let me double check everything. Sorry about that, everybody. Okay, looks good. Just double checking. It's always good to double check. Okay, must have did it wrong last year. I apologize. Move on to 3, 2. And finally 3, 3. Okay. A lot of products here, definitely. Okay, let's clean that up. Negative 41, negative 58, negative 75. Wow, crazy numbers there. Second row, negative 31, negative 44, negative 57. Third row, negative 21, negative 30, and negative 39. All right. Any questions? All right. Let's move on to the next page. This is weird, isn't it? Next page. Here we go. I'm going to go ahead and skip example 1. It's in the textbook, but I think we can skip example 1 for this video. I want to jump to example 2. It's much more interesting. Okay, so we have 3 matrices here, A, B, and C. They all happen to be 2 by 2s. Question: determine whether each equation may be true for the following matrices. Now, what I'm going to do is I'm going to fit in a third example first. So off to the left here, can everyone write down 2C? This is from the book. Is A times B equal to B times A question mark? Now, this is from geometry, the commutative property of multiplication. So write this down. Commutative property of multiplication. Okay, we're going to check for that. The second example, actually it's the first one on this note taker, is the associative property of multiplication. Write this down. And the third one should look kind of familiar from Algebra 1. This is the distributor property. Question, do these work with matrices? Do they all work? Do some of them work, or do none of them work? And we're going to explore that right now. Let's do A times B first. Here we go. They're all 2 by 2, so they will all match. So that's great. Even your final resultant matrix will be a 2 by 2 as well. Let me zoom in a little bit so you guys can see a little better. There we go. So here we go. Let's do 2C first. Okay, here we go. All right. Zoom. 2, -2, 1, 3, -4, and will it come out the same in reverse? That's the mystery, the $1,000,000 question. All right, let's write down the blanks here. And this will be a 2 by 2. And let's write in the addresses. I like to circle the rows of the first matrix and the columns of the second matrix to help me out there. Here we go. Let's do some mental math here. 3 times -2 plus 0 times 3. I love those ones. Yay. That's 1, 1. Okay, so I was concentrating on here and here a second ago in my mind's eye. We're now going to move to 1, 2 in my mind's eye. So let's do that one. Here we go. 3 times 1 plus 0 times -4. And yay. Let's move to the second row. Here we go. 2, 1. Let's do it. So it's -1 times -2 and -2 times 3. Great. And the last column. Well, in this case, it's the 2, 2. And we'll get this. -1 times 1 and -2 times -4. Yay. Let's clean that up. We'll get -6, 3, -4, 7. And let's check over here and do this side, okay? All right. Rows. Let's do that. There we go. So we'll get -6 plus -1. Right away, look. That's not even going to work, is it? You're not going to get the same answer. Let's just finish it off, though. 1, 2 is next. Because there's a reason why. We need it for later. It'll save us a lot of work. Trust me. Whoa, did I do it wrong? Dun, 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 dun. Oh yeah, I caught my mistake. Yay. I was wondering, I wrote down the matrix A wrong in the second half. This should be -2. Okay, that looks better. Sorry about that. I just want to be careful there. Oh my goodness. It is so easy to make a mistake. And let's move on to row 2, column 1. Might be hard to see without the highlight. Let's do it. 9 plus 4, fine. Talking to myself again. Not only am I talking, I'm recording, and I'm worried about mistakes. And 0 plus 8. Clean that up. 7, -2, 13. Oh, yeah. This is definitely not equal. A times B doesn't equal to B times A. Fail. Dun, 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 dun. So the commutative property of multiplication does not exist for matrix multiplication, sad face. All right. Let's go to 2A next and check to see if the associative property of multiplication works or not. And holy cow, order of operations here, we got to do AB for, oh, AB? That's cool. Didn't we do AB already? Oh yeah, there it is right there. It's AB. I'm going to transfer that to here. Nice. I'm going to take that matrix that I just got a few moments ago, -6, 3, -4, 7, and multiply that with C up here. 6, 2, 4, 8, and compare it to the other one. BC, oh, I don't have BC yet, so, yeah, I don't have BC yet, so I do need to do that. So I better do the BC first over here. So forgive me if I kind of cram, and I'll put on A times the BC over here. Yeah, that's probably a good idea to indicate that I still need to multiply by A. Yeah. Okay. Let's do that. And the BC, we don't know what that is. -2, 1, 3, -4. This is getting, I'm drawing these too big. I'm so sorry. I should probably shrink this down a little bit. Could I shrink this down? Let's take a look. Let's try that. Ooh. What? What is this black magic, Mr. Chan? Did it. Ha ha ha. Okay, great. All right, let's, yeah, this is a lot of work here. I'm going to do the AB times C first. This is here. Let's do it. 2 by 2. Put in the addresses. And let's multiply. Here we go. Row 1 of the first matrix and column 1 of the second matrix. I'm going to do some mental math there. Here we go. -36 plus 12. Yeah? Yep. That's fine. And then the second column over there, -12 plus 24. Sometimes I get lazy and not write down the plus sign there. Sorry about that. Second row, first column, -24 plus 28. And 2, the last two, -8 plus 56. Very good. And let's clean that up right here. So that's -24, 12, 4, and 48. Let's compare to the other side and see what happens over there, because we're trying to see if that works or not. Okay, we're trying to check it. So let's multiply over here. We're doing now BC. Okay, let's do it. BC. And the addresses. Gets a little cramped here, doesn't it? Yeah, definitely. We can zoom in a little bit more. Oh yeah, much better. So you guys can see better at home there. Whoops. Come on, technology. There it goes. Much better. Okay, much better. Here we go. -12, 4. Sometimes you get lazy and write down the plus sign, -4, 8. It's a little faster sometimes. 18, -16. 6, negative 32. Yeah, you don't need the plus sign, right? Who needs a plus sign? Let me double check all my numbers, make sure it looks right. That gives me, this is BC now. This is only BC right here, okay? I still need to multiply by A. So BC is 8, 4, 2, and negative 26. I still need to multiply by A. Let's do that right now. Bring that down. A is 3, 0, negative 1, negative 2, and bring down the negative 8, 4, 2, negative 26. I still got to do that, right? Oh my goodness gracious. And let's see what we get here. And we need more addresses. Okay, here we go. Negative 24. Oh, 0, sweet. All right, over here, 12. Oh, another 0. I love zeros. So 2, 1, positive 8, minus 4, nice. And the last, okay, great, negative 4, 52. What is this black magic? I don't know. What do we get here? Negative 24, 12, 4, and 48. Ding, 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 ding. No way, it worked. Spectacular. So the associative property of multiplication works with the 2 by 2 right there. So that's a yay. Smiley face. Ding, 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 ding. Let me zoom back out. I gotta do one more investigation to see if the distributor property works. Woo! All right, let's do it. All right, here we go. Draw a line to separate out my work here. Yay. So A plus B, let's add those together manually. Let's do that. A plus B, 3 plus negative 2, and then 0 plus 1. I'm doing it mentally up there. Negative 1 plus 3, and negative 2 minus 4 times C, right? Times C, check. Yeah. And then I have 1, 1, 2, negative 6 for my A plus B right there. Y'all see that? This is A plus B right there. That's what I just did. All right, I'm now going to multiply by C. C is 6, 2, 4, 8. Let's do the rows and columns. This will be a 2 by 2. Maybe less talking, right? You're kind of getting used to what I'm doing here. 6 plus 4, 2 plus 8, 12 plus negative 24. Holy cow. And 4 minus 48. Yeah, this is before the internet. So we get 10, 10, negative 12, negative 44. Let's check it with the other side and see if it works or not. AC plus BC, A times C. Let's do it. 3, 0, negative 1, negative 2. And C, of course, is 6, 2, 48. And oh, look at this. Didn't we do BC earlier already? Oh, BC is the purple, isn't it? Sweet. BC we did earlier is right here. I'm going to just plop that over here. And just add it at the end after I do A times C, okay? So this is plus negative 8, 4, 2, negative 26, okay? All right. There's a method to my madness sometimes here. So here we go. We're going to do the AC first, though. Let's see. It's a lot of work, definitely. Hang in there. Doing great, everybody. Here we go. 18, 0, yay, 6, 0, 6. Sometimes you can like get really good, fast mental math here. Double check all that. That looks pretty good. Yep. Oh, negative 6. That's what I meant to say. Sorry about that. Watch out for those negative signs. And this is 18, 6, negative 14, negative 18. And we're just adding the matrices at the end here. Did you guess correctly? 10, 10, negative 12. No way. Weird. Ding, 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 ding. Yes. This works too, the distributor property of a 2 by 2. So 2 yeses and 1 no. All right. Woo. Woo. We're going to go ahead and let's see. Oh yeah, we did that. We did that. 2C off to the side. This right here, this habits of mind, the commutative property multiplication was answered over there. The answer is no. The commutative property does not work. All right. Let's jump to the next page. Thanks for hanging in there. Good job so far. Ask questions if you have, if it's bugging you. Let's go to the next page here. This should go a little faster. All right. Identity matrices. Now, the word identity in math or algebra specifically is basically saying, hey, what do you multiply by to get back the same number? The identity with multiplication with regular numbers is the number 1. In a matrix, and by the way, an identity matrix is a square matrix with ones down the downhill diagonal. Think of a square matrix like this. The downhill diagonal is referring to this. You'll have all ones. Everywhere else will be zeros. So we have zeros here, like that. Zeros this way. Okay. Ones down the diagonal. When you multiply a square matrix with the identity matrix, you will get the same matrix. And that's what the identity matrix means. For example, take a look at 3A here. Circle the rows of 3A, multiply by the identity matrix, and see what happens. Here we go. A times 1, B times 0. Great, that takes care of 1, 1. Second product here, A times 0, B times 1. Okay, next element, row 2, column 1, C times 1 and D times 0. And finally, row 2, column 2, C times 0 and D times 1. When you clean that up, you'll get A, B, C, D, the same matrix. Any questions? Pretty straightforward. That's called the identity matrix. Write this down, identity matrix. Okay. All right. It's like multiplying by 1 with regular numbers. What happens if we, oh, look at B, this is kind of weird. What happens if we multiply by -1, 0, and 0, -1? That's kind of weird. Okay. Well, I'm just going to tell you this. It's just so much faster. This is the negative identity. And I'm going to generically write it off to the side. In fact, isn't this just -1 as a scalar multiplier? Isn't this just -I, everybody? And when you do that, you will get generically the same matrix, but with the opposite effect, like that. Okay, that's all. -1 scalar. That's all it is. No big deal. So when you look at this problem right here, and you recognize this is -I, just replicate the matrix you're trying to multiply by on the left with a negative sign. That's all. And that's pretty easy peasy. In fact, going back to the idea of the identity, here we go. It works both ways. Take any matrix, multiply by the identity matrix, which is a square matrix, and you'll get the matrix itself again. But did you know order doesn't matter with the identity matrix? It'll be the same if you do it the other way, if you put the 1, 0, 0, 1 in the front. So this is allowed in matrix multiplication, multiplying by its identity both ways. Okay. Yay. Now, the bottom habits of mind here reminds me of something you might find on an SAT, ACT. And I'm not going to skip this because this is pretty important. I've seen problems like this all the time. They want you to solve 4 variables, but the way they present the problem to you is it's using matrix multiplication as a start right there. They tell you individually A is a 2 by 2, B is a 2 by 2, and they tell you as a clue, when you multiply A times B together, matrix multiplication, you'll get this particular configuration, -1, 0, 3, 5. So what we're going to do is we're going to manually multiply these together and try to solve for J, K, L, M. Let's do it. And I've seen these before on ACT and SATs. This is something that we can't pass up, okay? All right, so here we go. Row. Okay, circle this. What's going on here? Getting glitch in the computer here. Let's try to catch up a little bit. Sorry about that. And column. Here we go. We're going to do 1, 1 now. -1 times J. Great. And then 0 times L. Awesome. I love the 0 right there. And that equals to literally -1. So it's a setup. You guys see that? That equals -1 right there. That's your equation. -J plus 0 equals -1. If I clean that up, I'll get -J equals -1. J equals 1. Ding, ding, ding. There's one answer right there. Sweet. Okay. Row 1, column 2. Here we go. Let's do this one. It'll be -1 times K plus 0 times M. Nice. This one equals to this part over there. Maybe I shouldn't be circling these to confuse the heck out of you guys. I'm just doing the corresponding values, okay? Let me not circle those to confuse the heck out of you. So right there, -K plus 0 as a second setup equals 0. K equals 0. Bam, there's my second answer right there. Row 2, column 1, here we go. 3 times J, great. And then 5 times L. That's another equation I need to figure out. And that equals to 3 on the other side. Didn't we just find what J is a second ago? Substitute into there. 3 times 1 plus 5L equals 3. 3 plus 5L equals 3. 5L equals 0. L equals 0. Great. Oh, I meant to do that in blue. Sorry about that. And then finally, I need one more. That's probably going to involve M's. Yep, it does. Here we go. Okay, 2, 3K, and 5M. Awesome. 3K plus 5M equals 5. K was 0. Sweet, from earlier. Up there. So that zeroes out. 5M equals 5. M equals 1. Whoa, this is crazy. That means my final matrix for B, matrix B is what we're trying to solve for right there, is J, K, L, M. J is 1, K is 0, L is 0, M is 1. What? We just produced the identity matrix? Nuts. So that tells you that B was like, oh, I just realized something silly. Oh my gosh. I actually proved it. I didn't have to really prove it necessarily. All right, let's move to the last page. All right. We're going to find A, B, and BA, and to show it's not commutative that we proved earlier. Fine, let's do AB first. Okay, 3. This is number 5 on the last page here. And you know what? I'm going to let you do it. I'll do it quietly here. You guys try it. Look up if you get stuck. This way I won't talk too much. Mr. Chan, you talk way too much. Good luck. All right, let's do this. In green. A lot of basic math. You just have to remember what to multiply with what, of course. All right, I'm almost done. How about you guys? And clearly these are not equal to each other. And I've proven that the matrix multiplication is not commutative. All right. Any questions on number 5? Pause the video and check your numbers there. Oh, very cool. Look at that. Look at number 6 and 7. You're not paying attention. We are multiplying by the identity. Yay. You're going to get back the same thing. Sweet. Bonus. Yay. That was pretty sweet. Ding, 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 ding. And same goes for over here. We proved it to you twice now already. The lecture today. That was nice. That's identity. It's a square matrix with ones down the main diagonal, the downhill diagonal. Any questions about 6 and 7? Ooh, this is interesting. The coordinates of the vertices of a triangle are listed here with the 3 points. The coordinates are multiplied by this matrix 1, 0, 0, negative 1. Find the coordinates of the image of the triangle after the transformation. This is going to be fascinating for a lot of you who just came from geometry. And you put the vertices of the triangle in a 2 by 3 matrix. We're not going to multiply by this one. Almost looks like an identity matrix, but it isn't. What does 1, 0, negative 1 do is the question. I'm curious. It's been a while. So we have a 2 by 3. Time, oops. Whoa. Whoa. What's going on here? I can't multiply those, can I? Oh no. Those don't match. So there's a trick. Flip it around. So that doesn't work, unfortunately. Swap it around with that transformation. That's a good mistake to make. All right, here we go. Now we can do this. It's a 2 by 2 times a 2 by 3. The inner numbers match. My final matrix will be a 2 by 3 matrix. Ha 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 ha. Let's write the matrices down. And let's do the products here. All right, so -2, 0, 1, 0, 2, 0. Great. Oh, let's use a different color here. Oops, wrong color. Purple. 0, -3, 0, -1, and 0, 1. Let's take a look at what our final transformed triangle is. It is -2, 1, 2, -3, -1, 1. And if we compare that to the original problem, what change? You notice in row 3, all the y values are opposite of the original triangle. Interesting. All the y values are opposite. So if you think about a coordinate plane, what happens to a triangle? Let's just kind of eyeball this really quick. -2, 3, 1, 1, and 2, -1. What happens to that triangle when all those values flip on us? -2, -3, 1, -1, and 2, 1. Oh yeah, there we go. Oh, it's been reflected, ladies and gentlemen. Ding, 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 ding. This is a vertical reflection. Interesting. Something you might see from geometry. This is a reflection across the x-axis. Interesting. All right. That was a cool last problem to see the transformation there. Whoops, that's C prime. Any questions, let me know. But thank you very much. See you next time. Have a good day.